Perfect. Thanks,
Yes,
Heidi.
all good. Thank you.
Okay. Good afternoon, everyone. Yes, I'm Heidi Roberts from ABPmer. I'm just presenting. It's going to be a little whistle-stop tour of the paper that we produced on transport and infrastructure. I'd also like to thank my co-authors, that's Tony Brooks and Johnny Coyle from ABPmer. Jan Brook, who's an independent consultant, and I think is here today, and she provided all the input in terms of ports and shipping, so thank you very much. Also, Katie Hodge and Jessica Ames from the Met Office provided a lot of that important information on what's currently happening, and Michael Clare and Justin Dix from the National Oceanography Centre from the NOC provided also important information in terms of the impacts on infrastructure. So, okay, so what are we talking about? It will be a whistle-stop tour because we are covering a huge amount of topics. So we're looking at coastal structures. We investigated, looked at power stations and energy infrastructure. We looked at water infrastructure, whether that's clean and wastewater, rail and road transport. Obviously, ports and shipping, as the name suggests, ports and and also other marinas and harbours, but also shipping and UK shipping and wider shipping. And I think the key aspect in terms of what we're thinking about and what's in the papers and the news at the moment is the offshore structures and the associated infrastructure. So that's things like the oil and gas platforms, offshore wind and renewables, the cables, and that can be the electricity cables, but also telecommunication cables, and also pipelines. So a huge amount of infrastructure that's around our coasts and seas. Also want to highlight that this paper should be read in conjunction with the other MCCIP papers, in particular the coastal flooding paper that was produced, I think presented on the first round by Ivan Haig at the University of Southampton and his co-authors. But there's also important papers there on sea level rise, the impacts on storms and waves, and also sea temperature. I think the key point, though, that I want to mention or need to make is that actually it's the exposure of our the exposure of our UK marine infrastructure to climate change is growing, and that is simply because we have more stuff in the sea. And with the government aspirations for a further 50 gigawatt of offshore wind by 2030, the amount of infrastructure in our marine environment is going to continue to increase significantly. And obviously there's also the associated transmission infrastructure with those.
Heidi, sorry to interrupt. We cannot see the full slide that you are sharing because there is a Teams window that has gone. Perfect. That's great. Thank you.
Thank you for that. Okay. All right. Now I'm just going to try and get that to change. Okay. Okay. So what's happening? The science. It's already written out there in a number of papers. So sea levels are rising. We know they're rising. They've been rising by about 1.5 mil a year since the 1900s. That's now accelerating between 3 and 5 millimeters per year. And we're also looking at, we all know about a metre of sea level rise by the end of the century. Water temperatures increasing, and Neil mentioned that earlier in terms of the increased frequency of marine heat waves. And those heat waves are predicted to increase under all scenarios. Important to note, I suppose, when we're talking about increasing sea temperatures and sea surface temperatures, that's also going to have, obviously, is having significant implications for the Arctic. But when we're looking at considering ports and shipping, that's potentially going to open those trans-Arctic shipping routes more frequently and for longer duration. And so the implications there for shipping. Coast is becoming more vulnerable to flooding and coastal erosion, and we know that there's about 20% of the UK coast is already susceptible to erosion, with a high proportion of that already subject to active retreat. That erosion is predicted to increase with sea level rise. But the changes in storm events is uncertain. Looking at the changes in potential changes in high winds, storms, and large waves, the picture is mixed and it's uncertain. And this is the most significant hazard for our offshore infrastructure. If we're looking at what's happening at the moment, peak wind speed is actually showing a downward trend compared to the 80s and 90s. Significant wave height has actually increased in the south of the UK, but decreased in the north of the UK over the last 30 years. And there's actually little or no trend in observed windstorms over the last 70 years. And the future is also uncertain. So if you're looking at the MCCIP 18 predictions, that does predict an overall reduction in mean significant wave height, but an increase in the most extreme waves. Wind speed could increase slightly, but we don't really know because the whole wider system effects and the global meteorological systems are called the uncertainty associated with those means we don't really know what's going to happen. And that is a significant area for concern. So if we jump into coastal infrastructure, there's a significant amount of coastal infrastructure around our coast. We know that. There's over 500 kilometres of coastal rail around the UK that's at risk of flooding and erosion, 25 railway stations. If we're looking at the water treatment systems, there's 22 clean water and 91 wastewater treatment works at current risk of flooding and erosion. That's likely to increase by 200% in England in the future. If we're looking back at coastal rail, that flood and coastal erosion risk is potentially going to increase by 400% in the coming years. And that's just for England, with 75% in Scotland and similar for around the United Kingdom. When we're looking at our power stations, we've already got 35 power stations currently at risk of flooding and erosion and 34 substations. And then when we're looking at that future flood risk, again, rising significantly in the future. And there's other coastal infrastructure around the UK that's at risk. If you think about coastal landfill sites, for example, the number of those that are at risk is predicted to increase in the future. And all of those are going to be potential risk of damage and failure as well. So that's both in terms of the flooding, but also in terms of the wave damage and associated storms. Also looking at the coastal infrastructure with respect to safety and operations. Wastewater CSOs have been in the public eye this winter. Obviously, the increase in rainfall that's predicted seeing already, and those changes in the weather and in rainfall patterns increase the risk of discharge from the CSOs, and that could be direct pollution from the contaminants within that, but then also, there's the increased precipitation in summer months, resulting in reduction in dissolved oxygen and implications there. So it's a winter and summer implications. And then if we're looking at sea level rise, then a number of these systems already are, use gravity to discharge. With increased tide locking, that potentially means that there's a change from the gravity systems to pump discharges and the associated costs and maintenance and actually operational risks associated with that. And then looking at increased water temperature. Again, wastewater treatment works, higher energy use, changes in performance. And our power stations, they use direct cooling water, which is why they're on the coast in the first place. And that reduced temperature differential, if we're looking at the changes between, the water that's abstracted and the water that's discharged, there's permit implications associated with that. Many of our estuaries and nearshore areas are protected for their marine ecology, and there is strict limits in terms of both the volumes, but also the temperatures that water can be discharged. So significant implications there in terms of the methods of operation, the types of operation, the costs of operations, and potentially having to adapt our cooling methods. So with that, over to our ports and harbours and the shipping, our shipping routes. I mean, 95% of goods that are entering and leaving the UK come by sea. So this is a significant amount of potential risk to the UK economy. Again, it's damage and failure of our port infrastructure, and most of that is through the flood risk. By the very nature of a port, it will be at risk of coastal flooding as sea levels rise. But also there's a risk of the combination of fluvial surface and groundwater as well. There's also increased risks from extreme heat and cold. So that can be things like changes on the implications for the mechanical parts, such as the lock or bridge operations, and also the plant and machinery. Also things like, well, the stored commodities that we have there. All implications, and there could be implications then for the need for more heating or cooling associated with protecting those goods, and also looking at extreme winds. A lot of our the port industry, the cargo handling involves very high cranes and other types of machinery, which are at 20, 30, 40 meters, and the extreme winds has that damage, both in terms of direct damage and failure, but also fatigue. Then we've got the impacts of shipping, navigation, and safety of operations. And actually, when a number of ports reported recently under the Climate Change Act, and that included Dover, Mersey, Sheerness, London, Southampton and Humber, all of them identified risks associated with storms. The changes in significant wave height, changes in wind speed and direction, and increases in storm surge on top of the sea level rise, and the impacts of disruption to the port operations, as well as the damage to infrastructure. And again, we're looking at the implications for safe navigation and safe operation on our ports, reducing the weather downtime and increasing the risk to our operatives. That could be with the berthing, it could be piloting, the cargo handling, etc. Weather downtime for ferry services. My office is next to the Isle of Wight ferry. It wasn't running for much of yesterday due to the storm. And if you're thinking about the ferry services between all the Scottish Islands, for example, there's significant impacts for community transport there, and in terms of the transport of people, but also cargo. Changes in sediment transport and dredging, again, implications for navigation and safety as a result of changes in sediment transport. There's increased potentially increased dredging costs, or certainly changes to the dredging regimes. Looking at the cost implications for that, and then some extreme cases, the potential economic viability of ports if their maintenance dredging requirements increase significantly. Also wanted to mention the inland and its external disruption I mentioned there. Basically, the interdependencies and cascading failures associated with these, and I think this is we're linked a lot with the coastal flooding paper and the discussions by government. Ports basically it's just a route between the suppliers and the consumers, and if we think about the interdependencies of that. As an example, so 2013 and 14, when we had the big storms there, the rail line between the Port of Immingham and Drax Power Station was flooded. That meant that the biomass couldn't get from the port to the power station. Luckily, it was reinstated before the power station had to close. Another less severe example, there's a rail flooding between Oxford and Southampton, which meant the minis that are produced in Oxford couldn't get to Southampton, so therefore couldn't be exported out at the time. So the disruption associated with both inland and actually seaward are potentially significant. So all the ports are likely to be affected. and all of them will be having to look at both the existing infrastructure and operations, but any new infrastructure and operations. The offshore, just finally looking then at the offshore industry, jumping through them, but actually what I also needed to mention when we're looking at ports and ports and shipping, but ports particularly, and this links very closely with the offshore industry. Obviously, we're going for the decarbonisation, which means there's a lot more infrastructure in the sea, which means there's a lot more offshore wind in particular. That offshore wind needs port infrastructure for the construction and the operation of those wind farms. And there's also that shift to a decarbonised economy. So there is potentially a lot more shipping going on. There's a lot more, there's changing nature of shipping and a changing nature of the energy industry. So, you know, looking at hydrogen and ammonia transport, new types of fuel, etc., that's all likely to require port infrastructure in some way, shape or form, which links to then the risks associated with really storms and storm events, you know, increased waves, increased winds, and the implications for storm damage to those structures, but also increased fatigue. And that could be through the engineering, the wind turbine generators, the blades, etc., through the wind and waves and the fatigue for that, but also looking at the cables and the pipelines and the anchors, the need for scour protection, mobile bed forms, the increasing storm events resulting in cable exposure, pipeline damage, etc. So it will increase the amount of maintenance that's likely to be required, and it increases the weather downtime as well. We need to, you know, the vessels that need to go out to maintain those structures. If you're looking at oil and gas, the transportation to get the operatives on and off those structures. There's also wider considerations in terms of the energy and energy sector, in terms of the demand-driven stresses as a result of heat waves or when wind doesn't blow to the energy infrastructure, and also changes to the energy yields associated with, you know, changes in wind patterns associated with offshore wind. So it's a new and emerging industry, much of it, the offshore wind, if we're looking in particular. And so, to be fair, we don't really know the impacts because much of it hasn't been in the sea for very long. But we know that they're going to need to adapt, or we're going to need to adapt. There's going to be increased operational and maintenance costs. There's going to be increased structural checks. There's going to be increased engineering costs associated with the construction, operation and maintenance. And there's going to be increased spend associated with added redundancy. So my final whistle-stop tour, what are the challenges and emerging issues? I think I've mentioned it. There's more stuff in the sea. The expansion of marine renewable energy means a significant proportion of our nationally critical infrastructure is now being built in the marine environment. It's being put in deeper locations, more exposed locations. And that also needs that increasing amount and increasing network of associated transmission cables and interconnectors. So the risk of a damage to our energy network from climate change is therefore increasing as our exposure is increasing. And also as the lifespan of our marine infrastructure is extended, there's a need for improved data and models on changes to weather patterns, most notably wind and wave regimes, and actually how to adapt the designs then to a changing climate. And particularly there's a need to better understand and share the information on how climate change affects infrastructure performance, deterioration and threshold failure. The growth in marine energy is increasing the demand for port areas and the need for the construction, operation and the maintenance of those offshore wind farms means that's changing as well. And there's going to be increased use of our ports. There's a call from industry to understand the interdependencies and cascading risks associated with our nationally critical infrastructure, and for the UK government to provide the mechanism for those to be investigated and mitigated. And that was mentioned by the Joint Committee on the National Security Strategy back in 2022. Also, the level of understanding of climate-related impacts is uneven, and it's improving unevenly as well across the sectors. We all know, but we are comfortable with the level of evidence and data on flood damage and coastal erosion, but we don't know much on the information on storm damage to offshore wind infrastructure. And we recognise that much of that is probably commercially sensitive. But I suppose I wanted to just finish on a positive. There is a lot of research going on this. There's big, there's a lot of research programs. There's OIC and the ORE Catapult looking at, looking at the implications of putting all this marine infrastructure in the sea. And actually, there's changes in regulations. Businesses have to look at the implications of climate change on themselves. So there's an increasing awareness of large businesses and how because they now have to report, or they will shortly have to report, on the financial risks associated with climate change. So things are moving in the right direction, but there's still a huge amount that we need to understand, and particularly in terms of storm events and changing wave conditions. So that was a very much voice to stop tour. Thank you very much.